Welcome. Today we shall be discussing a topic, linear motion and rotary motion. By the end of this topic, you should be able to define linear motion, state laws of motion, define rotary motion, highlight types of rotary motion, discuss ways of converting rotary motion into linear motion. Let's begin. Linear motion is defined as the change in position of a body with respect to time or to another body of reference in a straight line. In other words, the movement of a body in a straight line is called linear motion. Right? There are different examples of a body performing linear motion. A car moving in a straight line from point A to point B is a typical example of linear motion. A mango that fell or falls from a tree down straight under the influence of gravity alone, which we call free fall, okay, is performing linear motion. Also, the movement of the piston in the barrel of a bicycle pump is linear motion, all right? So, such are examples of linear motion. Okay, so anytime we want to discuss motion, linear motion, there are different parameters that we must consider in discussing linear motion to enable us to understand exactly what we are talking about. Such parameters include here distance, speed, and acceleration, or you can say displacement, velocity, and acceleration. Okay, so when we talk about distance, we cannot actually discuss linear motion without considering distance, because distance simply means the gap between 2 points. The gap between point A and point B is the distance. So any body that is in motion covers a distance. Okay, so distance simply means the gap between 2 points in space. And speed, which is a measure of distance moved by an object in a given time. So if you can determine the distance a body covered in a given point in time, you have actually determined the speed of the body. Okay? Now, if a body is moving with a speed, we can also look at the rate at which the velocity of the body changes, all right, or the rate at which the speed of a body in a straight line changes. And that gives us an idea of what we call acceleration of a body. So a body is accelerating when there is an increasing rate of change of velocity of that body. Then we'll say that that body is experiencing acceleration. If the velocity is increasingly changing, then the body is experiencing acceleration. Okay, so we have laws, Newton's laws that govern motion. We have 3 laws. Newton's law of motion, there are 3 of them. We have the first law of motion, we have the second law of motion, we have the third law of motion, all right? Newton's first law of motion simply states that a body will continue to be in a state of rest or uniform motion in a straight line unless it is acted upon by an external force. So this law is otherwise called the law of inertia. Inertia here in this case is the reluctance of a body to change its position of rest or position of motion. For example, if I sit here, the way I'm seated here, until I stand up to leave here, I will continue to be here until Jesus Christ comes. Same thing happens if we have a book on the table. That book will continue to be on the table until maybe wind or any other force takes it away from where it is. That's how it is. A body can also be in constant motion in a straight line if no force acts on the body. For example, you have a bicycle or a ball rolling down a street, that ball will continue to roll if you remove the frictional force that exists between the surface of the ball and the ground. Then the body will continue to be in motion. That is what Newton's first law of motion is all about. That law tends to tell us that force is responsible for motion. That is to say, for a body to move from one point to another, a force has to act on the body, right? We have Newton's second law of motion, which states that the rate of change of momentum of a body is directly proportional to the applied force. That is to say, the rate at which a body changes, the momentum of a body changes, is directly proportional to the force. Of course, you know that momentum simply means the product of mass of a body and its velocity. So if you want to determine the quantity of motion of a body, is the body's momentum. So the rate at which this change happens is directly proportional to the applied force. In other words, if you apply little force on a body, the change in the motion of the body will be small. If the force applied is a great magnitude of the force is applied, then the rate at which there will be a change in momentum of the body will also increase like that, will be great too. So Newton's second law tends to explain to us that this force that causes a change in the position of a body can be measured. If I explain that mathematically, I can say here that this force is directly proportional to change of momentum, that is mv minus mu, where m here is the mass of the body, v is the final velocity of the body, and u is the initial velocity of the body, all over t, which is the rate of change. Okay, so but because of our level, I will limit myself to just the laws. I'm not going into details to other mathematical implications of the law. Okay, so this law tells us that this force can be measured by F equals ma. The force is equal to ma, where m represents the mass of the body and a is equal to acceleration. You already know that acceleration is, in my previous video I told you, acceleration is the rate of change of velocity of a body. So if you have v, mv minus mu all over t, we can bring out m outside, which is a common factor of mv and mu. When that happens, we'll be having that m bracket v minus u all over t. But you already know that v minus u all over t is acceleration. That's how that formula came, that this force is equal to ma. So we can actually calculate the value of this force by that simple formula, that force is equal to ma. Now, we also have the third law of motion, which states that to every action there is equal and opposite reaction. That is to say, if you hit your head on the wall will react on your head and you feel pain on your head. That is it. Action and reactions are equal and opposite. So the rate at which you exert a force on a body is the rate at which the body will also react on you. So Newton's third law has so many applications in nature, has so many applications. So, but I will limit myself to this for this video, okay? All right, so those are the three laws that govern motion. So number 1, number 2, number 3. Please take note of them. The first law is called law of inertia. Second law explains or gives us the magnitude of the force that causes motion. Then the third law here is Newton's third law of motion, which is saying that to every action there is equal and opposite reaction. Okay, so having said that, let's look at different applications of linear motion. All right, linear motion is applied in lever arrangement, in slots, in linkages, in slides. You know, if you imagine slots at maybe a barrel of your pen and the ink tube of your pen, right? We have such motion, we have linear motion in that regard. In the form of slides, if you have ever used a table that have a drawer, you know, that slide, you can slide out, you know, the drawer and push it back again. That is linear motion we have in that regard. And linkages in lever arrangement is linear, is applications of linear motion that we have in these areas. Okay, so let's look at rotary motion, so to say. Rotary motion. Another name for rotary motion is rotational motion. Okay, so rotary motion is just the movement of an object around a fixed point or a fixed axis. If an object, you know, moves in a concentric circle about a fixed point, such motion of the object is called rotary motion. We have examples of bodies that undergo rotary motion. Example is the DVD player spinning in the player, the DVD spinning in the player, or the compact disc spinning in the player is a typical example of rotary motion. The ceiling fan you have, okay, turning around about its axis, typical of rotary motion. We have even the hand of a clock moving around the clock face is also a rotary motion, right? The earth rotates around its axis, which is also a rotary motion, you know. So all these motions that has to do with the body moving around in a fixed point, okay, is called rotary motion. It has so many applications in technology. Rotary motion has so many applications, so many. So, but we're going to look at it as we progress. Just follow me. We have different types of rotary motion. We have the one-way rotary motion, we have the reversible rotary motion, we have one-way intermittent rotary motion, right? So in one-way rotary motion is just a way where the body rotates or moves or spinning continuously in one direction. It does not move in the clockwise direction and turn in the anti-clockwise direction. So if we have a rotation of an object, all right, or a body spinning such that it only goes in one direction, we say such rotary motion is called one-way rotary motion. We have an example of objects that perform one-way rotary motion. For example, the ceiling fan that you have in the picture there performs one-way rotary motion. The ceiling fan does not rotate like this, at the same time turn like this. If that happens, then maybe you have to change the terminals. But if it's designed like that, it only goes one way. It doesn't go this way and turns this other way also. Same thing also happens in the crankshaft of a running engine. The crankshaft of a running engine or even an electric motor, all right, the armature of an electric motor cannot spin in this direction at the same time spin in this direction now. If it is going in this direction, it maintains that direction, all right? Even the sewing machine, this circular sewing machine that we have, if it is only rotating in one direction. So such examples are examples of one-way rotary motion. We have it, you know, like that. Okay, so now we also have another type of rotary motion that we call reversible rotary motion. In this way, all right, the body moves in the clockwise direction, right, rotates in the clockwise direction, and followed by an anti-clockwise movement. Okay, so this kind of rotary motion is seen in certain equipment or devices like this car cassette, you know, this kind of car cassette that we have previously before compact disc were invented. If you want to reverse it, sometimes you can put it in auto reverse. As it's going like this, you can put it in auto reverse. It start moving this way too, to either rewind or play the other side of the CD of the cassette. Also, you have a case where the wiper of vehicles turn this direction and turn this direction. All right. Now, also in automobile, this kind of rotary motion is used. It's utilized in automobile in a reverse gear system. You know, in this way, we can have a car move forward and move backward, reverse also. Even a forklift in trains too, that's locomotive, they all make use of reversible rotary motion. This is where you can see it happen, okay? Now, we have the one-way intermittent rotary motion. In this case, the rotation is interrupted at specific time interval. All right, as the body is rotating in this, is at a certain time interval is interrupted. Okay, so the second indicator of our clock is a typical example of that. You can see it goes like this, tick it, tick it, right? So such is an example of one-way intermittent rotary system. All right, there are different ways we can convert rotary motion into linear motion, which is of great importance to us in the technology sector. For example, in rack and pinion of steering rack, you must have heard about steering rack. It utilizes this conversion of rotary motion into linear motion to be able to perform. All right, so let's look at it. We have also in screws, we have the crank and the slider, we have the cams, clutches, eccentrics. We're going to look at them and understand how the conversion is made in these devices or equipment I've just mentioned to you. Okay, so let's look at the rack and pinion, so to say. For example, in the steering rack, we have the pinion here. This is the rack. A driver now who wishes to turn his vehicle to the left side will have to turn the steering. As he turns the steering, we have the pinion, right, moving along the rack. As it's moving along the rack is moving linearly in that direction. That's how we're able to turn left when you turn your steering like this, which is the pinion is turning over the rack. Then the rack moves linearly in that direction. Your car moves in this direction. When you also turn, you know, the pinion again, the rack moves linearly in the other direction. So that way, we're able to achieve such motion. Okay, so we can convert rotary motion to linear motion using a rack and pinion. I've given you a very concise example of that, what happens in that case. In screws, for example, if you want to fasten a screw in wood, no matter the kind of screw it is, all right, all you need to do is turn the screw. You can screw it in and unscrew it too out, depending on what you want to do. So if you turn the screw about its axis, the screw goes linearly into the wood. But when you turn it in the anti-clockwise direction too, as you turn it in the anti-clockwise direction, it's also moving out of the wood linearly. So such, it's a way we can convert the rotary motion of this screw into linear motion to use it as a fastener into the wood. Okay, so we have other examples here, like the use of clutches. Of course, you know that the clutch is a friction, very, very high coefficient, a device that has a high coefficient of friction. All right, so the clutch itself helps to actually should I say, transmit the power you have in the engine of a vehicle into the driving shaft of the car, right? So this is what happens when you pedal down the clutch. What the clutch does is to actually bring the driving shaft, all right, and the engine together. So when that happens, you can change your gear, you can put your motor in drive, you can put it in reverse. So, but when this happens, it connects the rotational motion of the engine to be transmitted to the driving shaft of the engine by the use of the clutch. So, but the clutch also helps to ensure that we don't have both the vehicle and the transmission system moving at the same way. So it can disengage the shaft, it can engage the shaft when you want to move. So that's what basically the clutch does. Okay, so the rotational force of this engine is transmitted into the driving shaft. So from the driving shaft is connected to the propeller. So by this, the vehicle starts moving, in a straight line. Okay, so we also have another device here we have called cams. Of course, in automobile arrangement, we have cams. Now, this cam, what it does is that as the cam rotates, as it is turning, its rotation, right, causes the pins you see there, all right, rotation causes it to press downward inside. As it turns again, it moves up. As it rotates, as it keeps rotating, its rotation on the pin causes the pin to move downwards. All right. Now, in a normal car system, this pin here can be called the valve. Now, as the cam rotates, as it's rotating, the valve enters and opens and closes. As that happens, that way, we can have air enter into the combustion chamber of the vehicle so that we can have an air and fuel mixture and combustion will take place. So this movement of a cam here, as the cam is rotating, it is converting the rotation into linear motion of the valves. Of course, you know that the valves has got springs that when the cam presses on them, the spring, relapses and they go down and open for air to enter. That is what happens in the system, the combustion system of an engine. Okay, so we also have another way rotary motion can be converted into linear motion by eccentric arrangement. Eccentric arrangement is more like the cam arrangement. Okay, so in this way, when we have a disc or a shaft, all right, rotating on a pin. So as it moves on this pin, the pin which is on a spring presses it down. The other rotation causes the pin to go up. So this movement of the shaft around this causes this pin to move up and to move down, which is a linear motion. Okay, so having said this, I want to take you to ExamGuide app. Let us take some questions on ExamGuide app where we're going to see what I've taught you, how it is used, how we can answer questions based on this. Like I said before, that the ExamGuide app is an app I strongly advise you to download this app in your PC, all right, because this is the best app for you. When you practice with this app, you see yourself improving in technology as the day goes by. Okay, let's go through it. The movement of the piston in the bicycle pump shown below illustrates dash motion. Of course, you understand what we're talking about. This is a bicycle pump, this is the barrel, this is the piston. The movement of the piston here indicates what kind of motion. Is it linear motion? Is it oscillatory motion, random motion, rotary motion, translational motion? Okay, the movement of this piston here is linear motion, which is option A, because for you to actually force air through the barrel of the pump to the tire, you have to move the piston up and down, which is linear motion. So that movement is linear motion. Okay, so let's look at other questions. The screw jack converts rotary motion to dash motion. A, circular motion. B, linear motion. C, oscillatory motion. D, random motion. E, zigzag motion. We just discussed here now that one of the ways to convert rotary motion to linear motion is by the use of screw. So the screw jack converts rotary motion into linear motion. Okay, we have many other questions here, many other questions we can point at as regarding this topic, but for want of time, we want to stop here. Please keep practicing with ExamGuide app. Thank you.